Hi guys, my name is Muhammad Aiman Najmuddin, and today I will be explaining on ocean iron fertilization. So let's get started. So the topic that we'll be covering today is the history of iron hypothesis, area of iron fertilization, iron climate relationship, ocean iron fertilization experiment, success or not, future of ocean iron fertilization experiment. So, what is iron fertilization? It is actually one of an idea proposed to relieve and resolve the problem of global warming. Its definition is an intentional introduction of iron into an iron poor area of the ocean surface in order to stimulate the production of phytoplankton with the intention of enhancing biological productivity and or accelerate carbon dioxide sequestration from the atmosphere. So, what was the reason for the idea to be proposed? In the 1980s, there is a development on the capability to measure the CO2 content or carbon dioxide content of ancient air trapped in ice. Carbon dating of the samples from the ice core shows strong indication that the atmospheric carbon dioxide concentration during last glacial period was lower compared to current time. John Martin, an oceanographer, hypothesized that the reason for low atmospheric carbon dioxide during the last glacial maximum was due to an increased dust input which bring iron to the high nutrient low chlorophyll region, also known as HNLC, that enhanced biological pump, also known as marine carbon pump. The main objective of ocean iron fertilization is to test Martin's hypothesis. In order to test Martin's theory, the researchers need to find an area to conduct the experiment. The area in which the researchers are interested are the Gulf of Alaska, Antarctic Ocean, and Equatorial Pacific Ocean. This area has an adequate sunlight and nutrient. However, the phytoplankton population in that area is relatively low. So, how does iron and climate relate to each other? Iron is a micronutrient which is very important to phytoplankton as they stimulate the uptake of macronutrients such as nitrate and phosphate, which are important in the phytoplankton growth. As they consume more macronutrients, the plankton begin to undergo photosynthesis, which takes carbon dioxide from the atmosphere to convert into oxygen and organic matter. As less and less carbon dioxide are in the ocean, carbon dioxide from the atmosphere will begin to dissolve more into the ocean through the process of the biological pump. The decrease of carbon dioxide in the atmosphere will allow more heat to escape into the space. This will result in a net decrease in the Earth's average temperature, thus cooling the Earth. So, how many ocean iron fertilization experiments have been done? Since 1990, a total of 13 ocean iron fertilization experiments have been performed. All of them shows limitations, which are subduction of fertilized patch, single iron addition, insufficient experimental periods or duration to observe the full phases of biogeochemical responses from the onset to termination after iron addition, micro or macronutrient limitation, no export flux measurement in the deep ocean, light limitation by storms, entrainment of dissolved silicate into the fertilized patch by physical mixation, no direct measurement of export flux with sediment traps, high dilution rate by small patch size. So, is ocean iron fertilization experiment considered as a success? It is a success in proving Martin's hypothesis, where there is an increase in the phytoplankton biomass in a high nutrient low chlorophyll region due to iron addition, which results in the drawdown of dissolved inorganic carbon and macronutrient. However, the experiment is considered not successful as the net transfer of carbon dioxide from the atmosphere to the mixed layer depth of the ocean through biological pump is not fully understood or quantified. The impact of iron also varies due to environmental conditions, export flux measurement techniques, and other unknown factors. So, for future ocean iron fertilization experiment, what sort of improvement can we do? First of all, we can pick a better location. We have to pick a location that have high silicate concentration and low grazing pressure, as these two factors are in control of diatom blooms. Diatoms are species that play a major role in increasing the biological pump. An example of location that have high silicate concentration and low grazing pressure is the Southern Ocean. The second improvement that we can do is the time. Since we pick Southern Ocean as our location, the best time to do the experiment is likely to be on the early summertime, which is around late December to early January. This is because of three key factors: micro or macronutrient availability, light availability, and grazing pressure. The third improvement that we can do is the duration of the experiment. The duration of the experiment should be a minimum of around 40 days. This is because to detect the full phase of phytoplankton bloom, in order to determine accurately the amount of iron-induced particulate organic carbon exported out of the winter mixed layer. We should also monitor post-assessment of the effectiveness, capacity, and risk of ocean iron fertilization for at least 12 months after the experiment is terminated. The fourth improvement that can be done is the strategy of iron addition. The experiment need to use an approximate of 2 nanomolar iron concentration, a fertilized patch size of around 300 km square, the use of 2000 kg of iron 2, and the iron need to be released in a form of an expanding spiral or square in the eddy center with a regular interval of 1 km throughout the patch and must be done within 24 hours. The iron addition also need to be done a minimum of 2 or 3 at interval of 10 to 15 days. The fifth improvement that can be done is to trace the fertilized patch and also detect carbon sequestration. We can use neutrally buoyant sediment trap system and water column based thorium-234 method to direct flux estimate. The use of autonomous sinking particle profilers of a transmissiometer in order to record the temporal and vertical evolution of iron-induced particulate organic carbon stocks. The use of underwater video profiler is to provide a photographic history of the water column. The final improvement that can be done is monitoring the side effect of ocean iron fertilization experiment. In order to monitor it, we need the use of optical sensor equipment, autonomous mode profiler, and or autonomous benthic vehicle such as crawler, which is capable of performing long-term benthic oxygen measurement for a duration of around 12 months. So that's it for ocean iron fertilization. Thank you.